Hello, guys. I hope you're good. I'm also good. So we'll be discussing partial differentiation. So before we start with any question, I just want to remind you of what is partial differentiation. So partial differentiation, it's when we are given a function z with respect to y and x, and then we are supposed to look for partial derivative of z with respect to x, or partial derivative of z with respect to y. So like I've said, so we'll be given a function. For example, let me write down what I mean. Just a second. So we'll be given a function of z. We'll be given a function of z with respect to x and y, and then we'll be required to find partial derivative of z with respect to x, or partial derivative of z with respect to y. So another thing to note is that we don't denote the partial by using d, but we denote it by curl. By curl d. You see the way I've been writing this curl here, this curl. So that's how we indicate that we are differentiating partially. So there will be first order partial derivatives, as well as second order, as well as implicit. So for now, let's check first order partial derivatives. So that's just your partial derivative of z with respect to x, or partial derivative of z with respect to y. So what does this thing mean? It means that if we were to differentiate this z with respect to x like this, so with the use of that example here, and we are required to find the first order. So if we are required to find partial derivative of z with respect to x, and then we use this function of z equals to xy, then that means partial derivative of z with respect to x will be equals to, so we're going to keep y as a constant. So if you are differentiating with respect to x, you keep the other variable as a constant. That means for this case, we're going to keep y as a constant. Therefore, when we differentiate x, that's going to be 1, and then multiply by that constant y. And then if we were to require to find partial derivative of z with respect to y, then that means we're going to keep our x here as a constant, and then we differentiate with respect to y. So meaning when we differentiate y, that will just be 1, and then this will be equals to x. You get it, right? So that's just how we do partial derivative of x, a partial derivative of z with respect to y. So another thing is that we'll be given implicit partial differentiation. So how do we then deal with implicit differentiation, and how do they look like? So this will be, you'll be given a function of z with respect to x and y, but then z is not the subject of the given equation. Understand, it's not the subject of the formula. So you'll have to then use implicit differentiation, meaning that you are going to differentiate z as well, but multiply the derivative of z with respect to partial derivative of x, or partial derivative of z with respect to x, or partial derivative of y with respect to partial derivative of z with respect to y. That's what I'm trying to say. So let me just make use of an example. So implicit differentiation will be something like this. So you can have an example like x cube plus y cube plus z cube plus 6 what, x, y, z, which equals to 1. So this is what I was saying. Implicit differentiation, implicit partial differentiation, the way you're gonna see it in your exam is that you won't have z as the subject of the formula. You will instead have something that looks like this, whereby even if you wanna try to make z subject of the formula, you cannot be able to do that. So for you to be able to differentiate this, let's take for example, they say find partial derivative of z with respect to x first. Then that means you're going to differentiate this thing and then keeping y as a constant. That means y is a constant, but then when you differentiate z, you should multiply by partial derivative of z with respect to x. So therefore this is going to be 3x squared plus this is y cubed. So y cubed is a constant in this case, so this is going to be 0, and then plus z cubed, that's going to be 3z squared. And then since we differentiated z, we should multiply by partial derivative of z with respect to x, and then plus. So here we've got 6xy, so we're going to keep 6xy as another function, and then z as another function. So meaning we're going to treat 6xy as a single function and z as another function. So we're going to use product rule to differentiate this, because we have a function of x here and then z there. So let's start. So if when we start with the function of x there, that's just going to be 6y, because of when we differentiate x, we just get 1, then constant x 6y, and then we multiply by z, and then we say plus, because of we're using quotient rule, then we copy 6xy, and then we differentiate z, that's just going to be 1, but because of we differentiated z, that's going to be partial derivative of z with respect to x, and then this should be equal to the partial derivative of a constant 1, that's going to be 0. Then we just group out factors that consist of partial derivative of z on our left. So that's going to be partial derivative of z with respect to x plus 6xy multiplied by the partial derivative of z with respect to x, which then equals to minus 3x squared minus 3x squared minus 6yz. So I took it to my right, just like that. And then after this, what am I supposed to do? I'm supposed to make a partial derivative of z with respect to x as my common factor. So I'm going to take it as my common factor. That's going to be partial derivative of x with respect to 3. With respect to x squared will be, if I take it as a common factor, I will be left with 3z squared plus 6xy, which then equals to minus 3x squared minus 6yz. And then you make partial derivative of z with respect to x the subject of the formula, and then this should give you minus 3x squared minus 6yz divided by what? By 3z squared plus 6xy. And then yes, someone might decide to take a common factor of what? A common factor of 3. So if you happen to take 3 as a common factor on both the numerator and the denominator, you will be left with 3 into minus x squared minus 2yz all divided by 3 into z squared plus 2xy plus 2xy, like that. And then that simply just mean your partial derivative of z with respect to x will then be equals to minus x squared minus 2yz all divided by z squared plus 2xy. And then yeah, that should be your final answer. So that's just the theory behind this. So I'll use examples to explain this further. So for now, let's continue. So we've got this activity 10, whereby we are required to find partial derivative of x, partial derivative of z with respect to x, as well as partial derivative of z with respect to y. in each of the following equations. So we're given that z equals to x over y. So let's start with partial derivative of z with respect to x. So now our partial derivative of z with respect to x will be equals to, so if we keep y as a constant, then we're going to differentiate with respect to x. That's just going to be 1 over y. And then what? And then partial derivative of z with respect to y will then be equal to, so I'm just going to rewrite z here like this. So z will be equals to x y to the power negative 1, so that we can see how this goes. So this is going to be negative x divided by y squared. So that's how you're going to differentiate with respect to y's, because of they've kept x as a constant and then differentiated with respect to that. So we're going to subtract 2 there, multiply by that negative 1 there, and then we're going to get this after all. And then yeah, that was just it. Let's see if we can solve something different. So yeah, guys, feel free to pause the video so that you can work out on these problems by yourself and then resume later to check the memo, of course. So here's how we're going to do this one. So we have x multiplied by cos of x over y. So we're required to find partial derivative of z. We are required to find partial derivative of z with respect to x, as well as partial derivative of z with respect to y. So let's start. So if we start with the one of partial derivative of z with respect to x, this is going to be partial derivative of z with respect to x. Then we will be supposed to use product rule, because we have a function of x that multiplies another function of x. So let's start. So when we differentiate x, that's just going to be 1, and then we copy cos. So we copy cos of x over y. We copy cos of x over y, and then we say plus, because of we're using product rule. Then we then copy x. We differentiate cos. That's going to be negative sine of x over y. And then what? And then we should multiply by the derivative of x over y, because that's our argument. So remember, we're keeping y as a constant. That means we're just going to differentiate with respect to x there. So that's going to be multiplied by 1 over y, just like that. And then we can try to simplify this and say this is the same as what? This is the same as partial derivative of z with respect to x will then be equals to cos of x over y minus, because of this negative here, we'll multiply that positive, and then y, x divided by y. So that will be x divided by y multiplied by sine of x over y. And then yeah, that should be your answer for partial derivative of z with respect to x. Now let's look for partial derivative of z with respect to y. So partial derivative of z with respect to y will then be equals to, so we're going to keep x as a constant and then differentiate with respect to y. So that means this is a constant. We're just going to write it down here, and then we differentiate our cos. That's going to be negative sine of x over y, and then we differentiate with respect to y. This is supposed to give us negative x divided by y squared. Hope that makes sense, guys. And then we can just try to write it in the form of what? In the form of a simplified manner. So negative by negative will form a positive, then x by x will get then x squared. So this is going to be x squared divided by y squared multiplied by sine of x over y. And then yeah, this should be your final answer for that one. I hope you got it, guys. It wasn't tricky at all. It was not tricky at all. It wasn't tricky at all. Okay, so now we have z, which equals to 1 over root of x squared plus y squared. So we're required to find the same things, guys. We're required to find partial derivative of z with respect to x, as well as partial derivative of z with respect to y. So let's start with the one of respect to x. So allow me to rewrite z like this. So z will be equals to x squared plus y squared to the power negative 1 over 2. Allow me to rewrite it like that so that you all can see what is happening. So now let's differentiate with respect to x. So partial derivative of z with respect to x will then be equals to, we should keep y squared as a constant. So this is going to be negative 1 over 2. And then what? And then x squared plus y squared. Then we subtract 1 from negative 1 over 2. That's going to be negative 3 over 2. Then we'll multiply by the derivative of what's inside here. We remember y squared is a constant, so that's going to be just 2x, and then 2 and 2 are definitely going to cancel out. So we will end up being left with just partial derivative of z with respect to x will be x minus x, to be specific, divided by square root of what? Of x squared plus y squared to the power 3. That makes sense, right? We're just gonna take this exponent down, and then it becomes positive. Then we rewrite that exponent in the form of a root, and then yeah, we will get something like this. We should get something like that. So now let's differentiate that z with respect to y. So it's gonna be like the same thing, you can say, guys, because so we're just gonna have partial derivative of z with respect to y will be equals to, so I'm going to differentiate it from here. So that's going to be negative 1 over 2 x squared plus y squared to the power negative 1 over 2. We'll multiply by the derivative of what's inside there, but let's not forget that we're differentiating with respect to y, so meaning that x is a constant, so we're just gonna have 2y, and then what? 2 and 2, they cancel out. You will get something, oh sorry, that this is to the power negative 3 over 2. I don't know why I wrote 1 over 2 there. So yeah, it's going to be negative 3 over 2 because of all they have subtracted negative 1 there, and then we'll get negative 3 over 2. And then partial derivative of z with respect to y will be then equals to 2 and 2 will cancel out. You'll just get negative y divided by the square root of what? Of x squared plus y squared to the power 3, and then this should be your answer. And then yeah, that will be it for that one. So guys, just to remind you of something, please feel free to pause the video so that you can work out on this problem by yourself, and then resume later to check the memo, of course. So now we've got z, which equals to the tan inverse of y over x. We're required to find the same thing, partial derivative of z with respect to x, also partial derivative of z with respect to y. So let's start. So when we differentiate z with respect to x, that's going to be partial derivative of z with respect to, okay, let me rewrite it here. Partial derivative of z with respect to x will be equal to, just because of we're differentiating a tan inverse, we know that we should put a division sign, and then on our denominator we say 1 plus the argument squared. Our argument is just y over x, so that's going to be y oh, that's just going to be y over x, and then squared. And then from there we are going to also differentiate the argument on our numerator, but then we're differentiating with respect to x, so meaning that this is just going to, we're just going to keep y as a constant. Then when we differentiate with respect to x, we should get something like negative y upon x squared. I hope you understand where that comes from, because if we rewrite this, we're just gonna say this is y x to the power negative 1. Then you differentiate this with respect to x, you know, you can see that there's gonna be negative 1 and then minus 2. Then we take that minus 2 down, it becomes positive x squared. So that's where that comes from. So yeah, don't get tricked, guys. And then here on our numerator, we're going to make this squared to multiply the exponent of the numerator and the exponent of the denominator respectively, and then we'll end up getting y squared divided by x squared. Then we take out x squared as the common denominator to end up combining this term and that term, and then this should look like partial derivative of z with respect to x will be equals to negative y over x squared divided by what? Divided by x squared plus y squared, all divided by x squared. So that's how we took the common denominator. And then x squared, if we happen to take this x squared to come here on our denominator, then that x squared will cancel out with this x squared, and then we will end up getting something like what? Something like negative y divided by just x squared plus y squared. So that should be your answer for partial derivative of z with respect to x. And then of course we're not done, we should then find partial derivative of z, partial derivative of z with respect to y. So we are going to keep x as a constant this case, in this time around. So we're going to differentiate this thing the same. So just because of we're differentiating tan inverse, we should put a division sign and then say here, and then say 1 plus the argument squared. So that's going to be the argument squared. Then on our numerator, we differentiate this y over x. Remember, x is a constant in this case, so that's just going to be 1 over x, right, when we differentiate y. So that's just going to end up being 1 over x. And then we make this y squared over x squared. Then we take x squared as the common denominator to combine this guy and that guy. And then we will end up having something like partial derivative of z with respect to y will then be equals to 1 over x. All of this divided by x squared plus y squared all over x squared. And then from here we can see that if we happen to take this x to come here on the denominator, then that x will cancel 1x here, and then that 1x that will be left will go up there. Alternatively, we can just say that we can take this x squared to come here to the numerator, and then it will be x squared divided by x, and then 1x will be left there. So at the end of the day, we are going to have something like x divided by what? By x squared plus y squared. So that should be your answer for that guy there. So yeah, nothing tricky, guys. I hope you understand it and you got it. Okay, another thing here, or another equation that we have, we've got a to the power z plus y over z, which equals to what? Which equals to x squared. So we are supposed to find the partial derivative of z, partial derivative partial derivative of z with respect to x, as well as partial derivative of z with respect to y. So let's start. Let's go. So when we check our given equation, guys, hey, one more thing, please, guys, pause the video so that you can try this on your own and then resume later to check the memo, of course. But I really hope you'll get it. I believe in you, guys. I believe in you. You should believe in yourself as well. Yeah, let's start. So when we check this given equation, we cannot be able to make z the subject of the formula. So meaning we must differentiate this implicitly. So we're going to use implicit partial differentiation because of we cannot be able to make z the subject of the formula. So let's go. We're going to start with partial derivative of z with respect to x, meaning that we're going to keep y as a constant. So let's go. So we have e to the power z. So e to the power z, that's just going to be e to the power z when we differentiate it, but we should remember to differentiate, we should remember to multiply by the derivative of the exponent, which is the derivative of z. That's just going to be 1, but because of we differentiated z, we should multiply that by what? By partial derivative of z with respect to x for this case. And then we don't have to write ln of e because it's always 1, and then plus, remember y, it's a constant, so we're differentiating this with respect to z. That's just going to be what? Negative y over z squared. You understand where that comes from? We've dealt with this, guys. We've dealt with this. Just rewrite it as y z to the power negative 1. Then when we differentiate this with respect to z, that's just going to be what? Minus 1 will come here, then z to the power negative 2, then that z to the power negative 2, I take it down, it becomes like that. And then we should multiply this by what? By the partial derivative of z with respect to x, and then with this will then be equals to, remember we're differentiating with respect to x, so when we differentiate x squared, that's just going to be 2x, and then we make partial derivative of z the common factor. But before we do that, we can just say this. We can just multiply everything by z squared, or but it doesn't matter. We can just leave it like that. It doesn't matter, guys. So let's just do this. So let's take out partial derivative of z with respect to x. Partial derivative of z with respect to x as our common factor. Will then be left with e to the power. Will then be left with e to the power z minus y z to the power of minus 2, like that, which equals to 2x. Then we make partial derivative of z the subject of the formula. That's just going to be partial derivative of z with respect to x. We divide both sides by the left hand side brackets there, and then we will end up getting that it is equivalent to 2x divided by e to the power z minus y z to the power negative 2. And then yeah, that should just be it, guys. That should just be it. So let's find what? Let's then find partial derivative of z with respect to y. So partial derivative of z with respect to y, this is going to be the following. So now we are differentiating with respect to y, okay? So we should know that we're keeping x as a constant, and then one more thing, we're still differentiating this implicitly because of we don't have z as the subject of the formula. So let's go. So when we differentiate e to the power z, that's just going to become e to the power of z. Sorry for that. E to the power of z. Then we are going to differentiate. So because of we're differentiating an exponential function, we know that we should multiply by the derivative of the exponent, and that's the derivative of z, which is going to be 1. And because of we differentiated z, we should multiply by partial derivative of z with respect to y. And then we say we were supposed to say also multiply by ln of e, but that's just 1, so we don't have to write it. And then we are going to say plus. So we're differentiating with respect to y, guys. So when we differentiate this guy with respect to y, that's just going to be 1 over z, right? That's just going to be 1 over z. 1 over z. So that's just going to be 1 over z. 1 over... Oh, okay, so I'm making a mistake, guys. So we're going to use we can decide to use product rule or quotient rule for this one, because of we have as where we're differentiating with respect to y for this case. So y and z are both functions, so we have to use let's use product rule for simplicity, because of quotient rule I don't like it. It might make this a little bit complicated. So guys, don't be scared. We are going to write yz like this. So we're going to write I'm just gonna write yz as yz, or maybe let me write it down here. So yz to the power negative 1. So guys, y over z is equivalent to y multiplied by z to the power negative 1. But then let's make use of this one that I circled there. So let's make use of product rule. So when we differentiate y, that's just going to be, okay, this is z to the power negative 1, okay? So that is just going to be z to the power of negative 1, or 1 over z. So whichever you guys prefer. What do you prefer? It doesn't matter. Let's just write 1 over z, then it's fine. And then we're going to say plus, and then we copy y, and then we differentiate z to the power negative 1. That's going to be negative 1 over z squared. Negative 1 over z squared, which equals to the derivative of x squared. Remember, we're differentiating with respect to y. So okay, here we're not done here. We just differentiated z, so we should multiply by what? By the partial derivative of z with respect to y. And then we move. Now we differentiate x squared with respect to y. That's just going to be a 0, because of x squared is kept as a constant. So this is going to be equivalent to 0. And then what I'm going to do here, I'm going to multiply this term, that term, and that term by z squared. So when I do that, I will end up getting that z squared e to the power z will be multiplied by partial derivative of z with respect to y. Then when I multiplied 1 over z by z squared, I just get a z, right? So I'm just going to get a z here, which will be plus z. And then here, this negative here, this negative will multiply that one, we get a negative, and then I multiply by z squared, because I told you I'm going to multiply everything here by z squared. So z squared and z squared will cancel out, and then I will end up having y partial derivative of z with respect to y, which then equals to what? To 0 multiplied by z squared is still 0. Then I can take out partial derivative of z as a common factor. When I do that, partial derivative of z with respect to y as a common factor, I'll be left with z squared e to the power of z, and then minus y, which then equals to so I'm going to also take z across the equal sign. It will change the sign and then becomes negative z. And then from there we can do this. We can just solve for partial derivative of z with respect to y. This will then be equals to partial derivative of z with respect to y will be equals to negative z divided by z squared e to the power of z minus y. One might decide to take the common factor of -1, and then we will end up getting something like -1 into what? Into y minus z squared e to the power of z, and then negative and negative, they cancel out. At the end of the day, our partial derivative of z with respect to y will just be equivalent to z divided by y minus z squared e to the power z, and then this should be your final answer for that one. So yeah, you got it, right? You got it, you got it, you got it. Okay, now let's see if we can solve something else. So we have z which equals to x plus y ln of xy. So we should differentiate this using partial differentiation, and then find partial derivative of z with respect to y, as well as partial derivative of z with respect to x. So I like starting with the one of respect to x. So we can see that we have x plus y that multiplies another function ln of xy. So we are supposed to use product rule to differentiate the two guys, because of if I'm differentiating with respect to x, then x is there on, and also it's there that side on the other function. So meaning that I must use product rule. So partial derivative of z, partial derivative of z with respect to x will be equivalent to, when I differentiate x plus y with respect to x, that means y is a constant, so I'm just gonna have 1. So 1 multiplied by the other function, because of I'm using product rule, this will end up giving ln of xy, and then we say plus, we copy x plus y. So I copy x plus y, and then I multiply by the derivative of this natural log of xy. So meaning that whenever we differentiate a natural log, we know that we just copy the argument on our denominator, and then on the numerator we just differentiate the argument. So the argument is with respect to what? We are supposed to differentiate this argument with respect to x. So when we differentiate xy, y is a constant, so that's just going to be y, right? And then we try to simplify this. This will end up looking like y and y will cancel out, and then what's going to happen there? We'll just have partial derivative of z with respect to x will just be equals to ln of xy, plus after y and y they cancel out, we'll just be left with x plus y divided by x, just like that. And then yeah, let's try to find the one with respect to y, but this is going to be the same thing, guys. This is going to be the same thing, but let's do it. So partial derivative of z with respect to x, to y now in this case. Why am I writing x? I like my x, I'm kidding. Let's continue, guys. So when we differentiate z, that's going to be partial derivative of z with respect to y. Then now, because of y exists on this function as well as on that other function, we're supposed to use product rule. So when we differentiate this guy here, we're going to keep x as a constant. That means we're going to just differentiate y, which will be equivalent to 1. And then we copy the other function. That's just going to be ln of x, y. And then we say plus, because of we're using quotient rule, now we copy this function of x plus y. So we copy x plus y. Then we differentiate ln of xy. Remember guys, we're differentiating with respect to y, so meaning x is a constant. So we know that when we differentiate the natural log, we divide by the argument. So we divide by the argument, and then on our numerator we differentiate that argument. So when we differentiate xy with respect to y, that's just going to be x. And then x and x will chop each other, and then what happens, guys? We will just be left with partial derivative of z with respect to y will be equivalent to ln of xy, plus then x and x cancel out, and then we'll be left with x plus y divided by just y. And then yeah, this should be your final answer. So I hope you got it, guys, because that was an easy one. So let's quickly see if we can differentiate a few more examples so that you can familiarize yourself with what's happening. Okay, so let's start. So we've got z, which equals to the sine inverse of y divided by root of x squared plus y squared. So let's go. So when we differentiate z, we know that it's just going to be a partial derivative of z with respect to what we are looking for. So let me just write down what we are looking for. We're looking for partial derivative of z with respect to x, as well as partial derivative of z with respect to y. So let's start with the one for x, guys. I love it. So partial derivative of z with respect to x. That's when we differentiate z there. So we know that when we differentiate sine inverse, we must put a division sign, and then on our denominator we are going to say square root of what? Of 1 minus the argument squared. So that's going to be square root of 1 minus the argument squared. So our argument is just 1 divided by the square root of x squared plus y squared, just like that. And then we square it, of course. And then on our numerator here, we are supposed to differentiate this whole argument with respect to x, meaning that y is a constant, guys. So allow me to write that argument like this. So allow me to write the argument in the form of this so that you guys can see what is happening. So this is the same as, so this argument here is the same as what I wrote here. So we're going to differentiate this with respect to x, so meaning y it's a constant, so y and y are constants. So this is going to be negative 1 over 2 y that was there outside, and then we say x squared plus y squared, and then we subtract negative 1 from here. That's going to be negative 3 over 2, and then we multiply by the derivative of what's inside here. Remember, y is a constant, so that's just going to be your 2x. So already you can see that 2 and 2 are going to cancel out, and then we can rewrite this with respect to a positive exponent, meaning that we're going to take it down and have a division sign, and then y and x will multiply each other there on our numerator. So we will end up having something like partial derivative of z with respect to x will just be equivalent to negative yx divided by the square root of what? Okay, let's not write it in the form of square root. It's good that way. Let's write it in the form of x squared plus y squared to the power 3 over 2. Let's not change it into a square root, divided by, so I just wanna avoid the big division sign, so I'm just gonna rewrite this using division, then the other bracket there. So that's going to be, we have a square root here, and then that's going to be 1 minus y squared divided by, so I'm going to multiply this squared is going to multiply the exponent of the numerator and this denominator, so we'll end up having y squared, and then that squared will definitely chop this radical sign here, and then that will end up being y squared divided by x squared plus y squared, guys, y squared divided by that. And then what I'm going to do from here, I'm going to combine this term and that term by first taking out x squared plus y squared as my lowest common denominator, and then combine the two inside the root there. So partial derivative of z with respect to x will just be equivalent to negative yx divided by x squared plus y squared to the power 3 over 2, then that's divided by the root is still there. Then when we combine the two terms, taking out x squared plus y squared as the common denominator, we'll get x squared plus y squared, and then minus the y squared that was already there. This is divided by y squared plus x squared plus y squared, yeah. And then we can see that y squared will definitely chop y squared, and then we'll be left with x squared. And then from there, I'm going to make x squared to have its own radical sign, as well as x squared plus y squared to have its own radical sign. So square root of x squared will just be x. So what I'm trying to say here is that partial derivative of z with respect to x will then be equals to negative yx divided by x squared plus y squared to the power 3 over 2, and then I say divided by the root. Okay, root of x squared, I told you it will be x, and then root of that will just be x squared plus y squared all to the power 1 over 2, right? 1 over 2. And then I'm going to change this division sign into a multiplication sign. Then partial derivative of z with respect to x will then be equivalent to negative yx divided by x squared plus y squared to the power 3 over 2. So this will be multiplied by, so when we change this division sign into multiplication sign, we must flip the numerator and the denominator, so we'll end up just getting x squared plus y squared to the power half, and then all of this is divided by just that x. And then we can see that x and x will cancel out, and then this term and that term are the same, so we should subtract their add or subtract their exponents. So this is going to be 3 over 2 minus half. You will end up getting 1, positive 1, right? When we subtract 1 over 2 from 3 over 2, we'll get 1. We'll get 1. So we should end up getting something like partial derivative of z with respect to x will be equivalent to what? To negative y divided by x squared plus y squared. And then, yeah, that should be your final answer for for that one. So let's now solve that given equation with respect to y. So let's differentiate it with respect to y, because we just did with respect to x. So guys, remember to pause the video so that you can work out on this problem by yourself and then resume later to check the memo, of course. So let me just rewrite z. So we have z, which equals to the sine inverse of what? Of y multiplied by x squared plus y squared to the power negative half. So that's what we have, and we're required to find what? Partial derivative of z with respect to y. Okay, yeah, so let's go. So we can say that when we differentiate z with respect to y, that's just going to be partial derivative of, that's just going to be partial derivative of z with respect to y. And then we differentiate sine inverse, we must put a root, right? We are going to put a root, so that's going to be on our denominator. We'll end up getting square root of what? Of 1 minus the argument squared. So the argument is the same as y divided by the square root of x squared plus y squared, and then we square this, and then from there we are going to differentiate the argument on our numerator. So this argument, we're going to differentiate it here on our numerator. So we have y here, and y exists as well as on the other function. So we should use product rule to differentiate the two guys because of the way I wrote it. Well, yeah, let's just go with product rule. I feel like it's gonna make our life easier. Yeah, let's go with product rule. So this is how it's gonna be. When we differentiate y, that is just going to be 1, and then we copy the other function, of course. That's going to be the root of what? Of x squared. No, I'm saying that's just going to be x squared. Okay, when you differentiate y, it is 1, guys. So we're just gonna copy this. So I just want to write this with respect to a positive exponent. So allow me to write it in the form of saying that this is the same as 1 over root of x squared plus y squared. You understand? And then because of we're using product rule, we're going to say plus, and then we copy y, and then we differentiate this guy with respect to y, so meaning x is a constant. So when we differentiate this guy, we should get something like negative 1 over 2 multiplied by x squared plus y squared to the power negative 1 over 2 minus 1. That's going to be negative 3 over 2. And then we differentiate what? We differentiate what was inside there because of we're using general power rule. And then we differentiate x squared, that's just going to be 0 because of it's a constant. We differentiate y squared, that's just going to be 2y, right? And then we can say that this 2 will cancel out with this 2. This negative will multiply that one, and then what? And then we'll just be left with what? We'll just be left with okay, 2 and 2 cancelled out as well. We'll just be left with y squared. Okay, let's rewrite what we'll be left with. So partial derivative of z with respect to y will just be equivalent to 1 over a root of x squared plus y squared, and then minus 2 and 2, they cancel out, y and y, they multiply each other, we'll get y squared, and then of course this negative, multiply that one to get a negative, and then we're going to rewrite this with respect to a positive root. So this is going to be what? X squared plus y squared to the power 3 over 2, just like that. And then yeah, let's verify if we didn't miss anything. I don't think we missed something. Okay guys, you see this term here, this term of a root of x squared plus y squared. Please allow me to rewrite in this following manner: 1 over 2, so that you all can see what's happening. All right, yeah, and then I want to avoid a big division sign, so I'm going to rewrite the denominator using this manner. So this squared will multiply the numerator as well as the denominator. The exponent of the numerator and the exponent of the denominator will end up getting y squared divided by x squared plus y squared. Because of this squared will cancel out this radical sign, so we'll end up having square root of what? Of 1 minus y squared divided by x squared plus y squared. So, and then after that I'm going to combine this term and that term. So I will take out x squared plus y squared as the common denominator and then combine the two. So we'll end up getting x squared plus y squared and then minus y squared. That's just divided by x squared plus y squared. Okay, and then we can say that y squared cancel out with y squared. We'll just be left with y squared there, x squared I mean, and then divided by that. So on this other side we should as well as take the lowest common denominator there. So this is going to be what? Partial derivative of z with respect to y is equivalent to the following. So where our lowest common denominator here is going to be x squared plus y squared to the power 3 over 2. So this is going to be this lowest common denominator divided by that. We should get something like x squared plus y squared to the power 1. Then we'll multiply it with 1. So we're going to get x squared plus just y squared, and then we say minus, this minus is coming from here, and then we can write the y squared same time, and then we say this divided by that, just 1 multiplied by that numerator, which is just y squared. Okay, so it's nothing fancy that I did there. And then we are going to say divided by, so this side we agree that y squared and y squared will cancel out, and then we will be left with what? We will just be left with just x squared. So I'm going to make x squared to have its own radical sign, as well as x squared plus y squared to have its own radical sign. So at the end of the day we'll have square root of x squared, which is just x, which is just x divided by what? By the square root of x squared plus y squared. But please allow me to write this square root in the form of in this manner, like in this manner. Yeah, yes, thanks for understanding. All right, when we check our left hand side here, we can see that partial derivative of z with respect to y is equivalent to, so y squared and y squared will cancel out. We'll just be left with x squared, which is divided by x squared plus y squared to the power 3 over 2. And then we're going to change this division sign into a multiplication sign and then flip the numerator and the denominator. So we'll end up getting what? X squared plus y squared to the power of half divided by x, and then x squared and x, they are going to cancel out. 1x here will cancel out with 1x there, and then we can see this term and that term, they are the same, so we can add or subtract the exponents. So 1 over 2 will be subtracted from this 3 over 2, and then we'll just be left with 1. So at the end of the day, partial derivative of z with respect to y will be equals to x, divided by x squared plus y squared, and then yeah, that should be your final answer. Yeah, thanks for understanding, guys. That was simple, and I hope you got it, guys. I hope you got it. I hope you're following and you get what is happening. So guys, feel free to pause the video so that you can work out these problems on your own and then resume later to check them home. So now we have yz plus xz plus xy equals to 0. So we are required to find partial derivative of z with respect to y, x, as well as partial derivative of z with respect to y. So let's go. Let's start with the one with respect to x. So when we check our given equation, we don't have z as the subject of the formula, but for this question you can make z the subject of the formula, and then you should be able to get to the same answer. So I'm just going to use the method of differentiating this implicitly, because I want you to get what is really going on with implicit differentiation when it comes to partially implicit. So yeah, let's go. So we're going to differentiate with respect to x first, so meaning that y it's a constant. So when we differentiate y it's a constant. So when we differentiate z, that's just going to be y, and then we differentiate z, it becomes 1, and then because of we differentiated z, we should multiply by partial derivative of z with respect to x, and then we say plus we now differentiate x z. So remember, we're differentiating with respect to x, so x and z are both functions, so we should use product rule to differentiate this guy. So when we differentiate x, we're just gonna get 1, and then we copy z, we say plus because of we're using product rule, and then we then copy x, we differentiate z, it becomes 1, but because of we differentiated z, we should multiply by the partial derivative of z with respect to x, and then we say plus, remember y it's a constant, so when we differentiate x, it's just going to be that constant that will be left, and then we differentiate 0, that remains as 0. Then we can take out factors that doesn't consist of y, of partial derivative of z with respect to x to go on our right, and then we just leave factors that consist of partial derivative of z with respect to x on our left. So, and then take out the common factor, the value of partial derivative of z with respect to x taken as our common factor, will be left with y plus x, right? And then this will be equivalent to negative z minus y, and then we make partial derivative of z the subject of the formula. That's going to be partial derivative of z with respect to x will be equivalent to minus z minus y divided by y plus x. So this should be your final answer for partial derivative of z with respect to x, and then we now find partial derivative of z with respect to y, so meaning that x is now a constant. So we start, we have yz, so we should use product rule because of we have yz, and now we're differentiating with respect to y, right? So we're going to use product rule. When we differentiate y, that's just going to be 1, and then we copy z because of we're using product rule, so it will be z, and then we say plus, we copy y, we differentiate z, that's going to be partial derivative of z with respect to y, and then plus we have what? We have xz. So xz, remember x it's a constant, so we're just going to differentiate z, and then we'll get 1 multiplied by that constant. Because of we differentiated z, we should multiply by partial derivative of z with respect to y, and then we move to that other term of xy. Remember, x is a constant. We differentiate y, that becomes 1 multiplied by that constant, and then 0. When we differentiate it partially, it still becomes 0. And then of course we are going to group out factors that consist of partial derivative of z on our left, and factors that doesn't consist of partial derivative of z with respect to y to be on our right. And then we take out partial derivative of z with respect to y as our common factor. We'll be left with y plus x, which is equivalent to negative x minus z, right? Minus z. And then what? And then we make partial derivative of z with respect to y as the subject of the formula. We are required to get something like just that. And then yeah, this should be your final answer for that guy. So yeah, I hope you got it, guys. It wasn't bad at all. It wasn't bad at all. So let's see if we can solve another one. So we then have we now have or maybe I should solve that one. No, let's leave it, guys. Let me just emphasize that for this question, you can make z the subject of the formula, and then you can later differentiate that partially, and then you will get the same answers, guys. You will get the same answers. I show you. I did it and it works. So yeah, for the sake of time, should I do it? No, I'm not doing it. I'm not doing it, guys. I hope you're gonna do it. So yeah, I'm chasing timing, but let's do it, guys. Let's just do one. Okay, let's just do one. You'll do the other one. So okay, let's take this one down. Let's take this one down. Okay, guys, let me rewrite this. So we have yz is equals to what? It is equivalent yz plus xz equals to plus xy plus xy equals to 0. So if we make z subject of the formula here, we are going to get that z will be equivalent to negative xy divided by y, divided by y plus x, right? Y plus x. So this is going to be your z. Yes, you'll take x plus y across the equal sign, and then you make z subject to the formula, and then yeah, you will get something like this. So when we differentiate z partially, so this is going to be partial derivative of z with respect to x. This is just going to be what? So you have x on both the numerator and the denominator, meaning that you should use quotient rule to end up differentiating this guy. So this is just going to be what? This is just going to be the quotient rule. You're going to use it in this following manner. So this is going to be y plus x and then squared, and then from there you just square the numerator, and then now we should remember to keep y as a constant. So when we differentiate this numerator here, we are going to just get negative y, right? Negative y, which multiplies what? Which multiplies our denominator, which is y plus x, and then we say minus because of we're using quotient rule. We copy the numerator, we differentiate the denominator with respect to x. That's just going to be 1. That's going to be just 1. Okay, and then we can just say this partial derivative of z with respect to x will then be equivalent to minus y squared minus yx plus xy. You can say that the negative and the negative will multiply, and then we'll just get positive xy, negative y squared, negative yx, just like I wrote there. And then this is divided by y plus x, and then squared. Okay, so what's gonna happen here is that we are going to write it in this following manner. Okay. okay, let's go, guys. So let's go. So we are going to get the, we can see that minus yx and positive yx, they cancel out, so partial derivative of z with respect to x will be just be equals to negative y squared divided by y plus x. So okay, just to take you back, I want to show you something. You can see this is what we got when we made z the subject of the formula. So when we didn't make z the subject of the formula, we got this, which was minus, so let me copy it down. So when we didn't make z the subject of the formula, we got that partial derivative of z with respect to x was equivalent to what? To negative y negative z divided by x plus y. This is what we got. So look, guys, I want to show you that this thing is the same. So partial derivative of z with respect to x. So what we're going to do, we're just going to substitute z by what z is equivalent to. You'll see what's going to happen here. So we'll get negative y negative into negative xy divided by y plus x, and then all of these divided by x plus y. So let's multiply this whole thing by 1, but a constructive one. So let's multiply. We just want to eliminate this y plus x here. So what we're going to do is that we're going to multiply by x plus y divided by x plus y. This is 1, right? So I didn't change anything on our equation. So this is going to be partial derivative of z with respect to x, and then this numerator will multiply that numerator, and this denominator will multiply this denominator. So on our numerator, we'll end up having negative y, which is multiplied by x plus y, and then this negative and negative will multiply to form a positive, and then this one will multiply this whole thing, and then it will end up cancelling out, so we'll just be left with xy, right? And then this denominator multiplies that denominator, will end up getting x plus y squared, and then we multiply on our numerator there, we get negative yx minus y squared plus xy, all of these divided by x plus y squared, and then x plus y and positive xy and negative xy, they cancel out. We end up getting that partial derivative of z with respect to x is equivalent to what? To negative y squared divided by x plus y, and then squared. So this should be your final answer. So you can see that this guy and that guy, they are the same. So what I would like to emphasize is that even if you can be able to make z the subject of the formula, please do, you'll get to the same answer. If you cannot, then know that you are supposed to differentiate it using implicit partial. But even if you are lazy to make z subject of the formula, know that implicit partial is going to work for you. So yeah, so you can also try out that one of partial derivative of z with respect to x when you have made z the subject of the formula. You'll see you will get to the same answer, guys. So it is the same thing. Poraro, potato. It is the same thing. Yeah, let's go. Let's quickly continue and differentiate this one. So we have z, which is equivalent to that z over y. So we're required to find what? Partial derivative of z with respect to x, as well partial derivative of z with respect to y. So let's start with the one with respect to x, because I love it. You should love it as well. So yeah, let's go. Partial derivative of z with respect to x, what is it gonna be? What is it gonna be? It's going to be, so we're going to keep y as a constant, so meaning that we should just only differentiate z with respect to x. So when we differentiate z, we should multiply by the partial derivative of z with respect to x. So yeah, let's go. So y is a constant, guys. So when we differentiate z, we're still gonna just get 1 over y, and then because of the derivative of z is just 1, but because of we differentiated z, we should multiply that by partial derivative of z with respect to x, and then we say minus. So we're differentiating with respect to x, right? So meaning x and z are both functions, so we should use product rule. So when we differentiate x, that just becomes 1, and then we copy z, and then we say plus, because of we're using quotient rule, now we copy x, and then we differentiate what? We differentiate z, that becomes 1, but because of we differentiated z, we multiply by the partial derivative of z with respect to x, and then we now differentiate ln of 5. That's going to be, that's just a constant. So when we differentiate the constant, we get at 0. And then maybe we can try to rewrite these by saying what? We can say this is 1 over y, partial derivative of z with respect to x minus z minus x, partial derivative of z with respect to x equals to what? Equals to what? To 0. And then we make all right, we can multiply everything by y. Okay, so we can multiply everything by y here, so that we can eliminate this y and not end up having a fraction. So we'll just be left with partial derivative of z with respect to x minus zy minus xy, partial derivative of z with respect to x, which is equivalent to 0, because 0 times y, it will still be 0. Then we take out partial derivative of z as a common factor. So partial derivative of z with respect to x as a common factor will just be left with 1 minus xy, which will be equal to zy. So zy will be taken across the equal sign, and then partial derivative of z with respect to x will then be equals to zy divided by 1 minus xy, and then yeah, that's just it. So that's just your final answer there. Your final answer should look like something like zy divided by that guy there. So now let's look for partial derivative of z with respect to y. So maybe I can just rewrite the given function. I can rewrite, allow me to rewrite it in this following manner. So z y to the power negative 1 minus xz equals to ln of 5. Okay, now let's start differentiating. So we're differentiating this guy with respect to y. Okay, so let's go. So both z and y are functions, so meaning we should use product rule to differentiate that, and then what? X should be kept as a constant, and then yeah, let's go. So when we differentiate z, that's just going to be 1 multiplied by the other guy, and then we should, just because of a differentiated z, we should again multiply by partial derivative of z with respect to y. So this is going to be 1 over y multiplied by partial derivative of z with respect to y, and then minus, we differentiate oh, we're using product rule, guys. So we're using product rule. This is going to be plus. Why am I rushing? Why am I rushing? Where am I rushing? Why are you running? Okay. Let's go. So when we differentiated z first, and then we copied y to the power -1. So now we are supposed to copy z. We differentiate that other one of y. That's going to be -1 divided by y squared. And then minus, we differentiate xz with respect to y. So x is a constant, but then when we differentiate z, we get 1, and then we multiply that 1 by partial derivative of z with respect to what? With respect to y. And then this will be equivalent to 0 because the derivative of ln of 5 is 0. And then we're going to multiply everything here by y squared. So let's multiply everything by y squared. So when we multiply all the terms by y squared, we are going to get y squared divided by y. That's just y, partial derivative of z with respect to y, with respect to y, and then minus, because of this negative, we'll multiply with that one, and then the y squared will end up being cancelled, and then minus xy squared here. Xy squared multiplied by partial derivative of z with respect to what? With respect to y. This will be equivalent to 0. Then we take out partial derivative of z as a common factor, partial derivative of z as a common factor there. We will be left with y minus x y squared, which is equivalent to positive z, because we would have taken negative z across the equal sign. Of course, it's going to change the sign. And then partial derivative of z with respect to y is equivalent to what? Z divided by y minus xy squared. We can take out y as a common factor down there. We'll be left with 1 minus xy, and then yeah, that should be your final answer for that one. So yeah, that was it, guys. It was an easy one, right? It was an easy one. So let's see if we can differentiate something else. So the other else that we have is this guy. So we now have z cubed minus 3x squared y, and then plus 6xyz, which equals to 0. So we are required to find the same thing: partial derivative of z with respect to y, partial derivative of z with respect to x, as well as partial derivative of z with respect to y. So when we differentiate z cubed, that just becomes 3z squared, but because of we differentiated z, we should then multiply by partial derivative, what's happening, partial derivative of z with respect to x, because of I said I'm starting with partial derivative of z with respect to x, and then that's going to be, so we're keeping y as a constant, right? So this is going to be 3 times 2, that's 6xy, and then what? Then we differentiate, so we can see here we've got x and z multiplying each other. So let's keep 6xy as a single function and then z as another function. So meaning that we're going to use product rule. 6xy is multiplying z. So when we differentiate 6xy with respect to x, we're just gonna get what? 6y, and then we copy z, we say plus because of we're using product rule. Now we copy 6xy, and then we differentiate z, it becomes 1. We multiply by a partial derivative of z with respect to x, and then this will be equivalent to 0. The derivative of 0 partially is 0. And then we can take out factors that doesn't consist of partial derivative of z to be on our right there. So this is going to be partial derivative of z with respect to x plus 6xy partial derivative of z, and then what? And then this will be divided by what? By partial derivative of x, and then we take out all the factors that doesn't consist of that thing to be on our right. So 6xy minus 6yz minus 6yz yz, and then we take out partial derivative of z as the common factor. Partial derivative of z with respect to x as our common factor, will be left with just 3z squared plus 6xy, which will be equivalent to 6xy minus 6yz. And then what? We are supposed to make a partial derivative of z with respect to x as our subject of the formula. Will end up getting 6xy minus 6yz divided by 3z squared plus 6xy. Therefore, partial derivative of z with respect to x. So if we're going to take 6 as a common factor there on our numerator, we're going to take 6y. Let's just take 6y as a common factor. We'll be left with x minus z, right? X minus z. And then on our denominator, we take we can take 3, right, as our common factor. Yeah, let's just take 3 because we can take 3, we'll be left with z squared plus 2xy, and then 6 divided by 3, that's just 2. So at the end of the day, our partial derivative of z with respect to x will be 2y, and then x minus z divided by z squared plus 2xy, and then ta-da, that should be your final answer for that one. So yeah, let's see if, let's now solve for this guy with respect to y. So let's solve for him with respect to y, and then this guy should look like, okay, I can rewrite him, it's fine. Let me just rewrite the function. So the function is z cube minus 3x squared y plus 6x yz, which equals to 0. So let's find partial derivative of z with respect to y. So this is going to be what? This is going to be the following. So when we're going to keep x as a constant and differentiate that thing with respect to y. So z here, this is going to be 3z squared multiplied by the partial derivative of z with respect to y. So whenever we differentiate z, we should multiply by partial derivative of z with respect to y. And then minus, remember x is a constant, so that's going to be just minus what? Minus 3x squared, because of would have just differentiated y and then got 1, and then we multiply by the constant there. And then what? Now we differentiate further, we are going to get the following. We are going to get that, so 6xy, we're going to keep it as a single function and z as another function, so we're going to use product rule. So when we differentiate 6 xy with respect to y, we will just get 6x, and then we copy z because of we're using product rule, and then we say plus. Now we copy 6xy, we differentiate z, it becomes 1, then we multiply by partial derivative of z with respect to y, and then we equate this to 0 because that the derivative of 0 is still 0. And then we can take out factors that doesn't consist of partial derivative of z with respect to y to be on our right, and then those that do on our left. So we'll be left with 3z squared, and then partial derivative of z with respect to y plus 6xy, partial derivative of z with respect to y will then be equals to what? This will then be equals to 3x squared minus 6xz. 6xz. All right, then we solve this. So this is going to be partial derivative of z with respect to y. We take it as a common factor, we'll be left with 3z squared plus 6xy, which will be equivalent to what we had on our right hand side as 6xz. All right, then we do this. So partial derivative of z with respect to y will be equivalent to 3x squared minus 6xz divided by 3z squared plus 6xy. So we can take out the common factor of 3 on our numerator and denominator, right? So on our numerator we can take out 3x, that's going to be 3x into x minus 2z, x minus 2z divided by, on our denominator we can just take out 3, that's going to be z squared plus 2xy plus 2xy, and then 3 and 3 they cancel out. So at the end of the day, partial derivative of z with respect to y will be equivalent to x into x minus 2z all upon z squared plus 2xy. And then yeah, that's just it. And then yeah, I hope you got it, guys. So let's quickly check the equations here. So we now have, if z equals to sine of xy, we should show that 1 over y multiplied by the partial derivative of z with respect to x is equivalent to 1 over x multiplied by the partial derivative of z upon with respect to y, I mean. So yeah. Let's start. So the keynote is that we should find partial derivative of z with respect to x as well as partial derivative of z with respect to y. So let's start with the one of respect to x. So when we differentiate this given function of z with respect to x, so partial derivative of z with respect to x, it means that the derivative of sine, that's just cos of xy, then we differentiate our argument keeping y as a constant, then the one we differentiate x, that's just going to be y, right? And then we differentiate what? And then we again differentiate z with respect to y, that's just going to be cos of xy multiplied by x, right? Cos will then keep x as a constant, so when we differentiate y there, we'll just need to multiply with x. So therefore let's see, when we multiply, so therefore 1 over y multiplied by partial derivative of z with respect to x is equivalent to 1 over y multiplied by what? Cos of xy by y. And then we can say that the y and y will cancel out. We will just get cos of xy. Okay? And then another thing is that 1 over x multiplied by partial derivative of z with respect to x will be equivalent to 1 over x multiplied, this is with respect to y, will be equivalent to 1 over x multiplied by cos of xy by x, and then that is the same. X and x will cancel out, we'll just be left with cos of xy. Therefore, we proved that 1 over y multiplied by the partial derivative of z with respect to x is equivalent to 1 over x multiplied by the partial derivative of z with respect to y. So yeah, that's the proof. And then what? We then solve our last question, which is going to be this one. So this is the last question, guys. Hang in there. Okay, we have z which equals to x squared plus y squared minus 1. We should show that x multiplied by partial derivative of z with respect to x plus y partial derivative of z with respect to y is equivalent to minus 2z plus 1 plus what? Z. So let's see what can we do here. We can find our partial derivative of z with respect to x and also partial derivative of z with respect to y and see what we get there. So let's go. So z here, z is equivalent to x squared plus y squared minus 1 to the power minus 1. So when we differentiate this z with respect to x, we are going to get negative 1 of x squared plus y squared minus 1 to the power negative 2. Then since we're differentiating with respect to y to x, then y is a constant, so that's going to be just multiplied by 2x. And then yeah, I can rewrite this nicely by saying partial derivative of z with respect to x is equivalent to minus 2x divided by x squared plus y squared minus 1. Okay, and then what? So let's go. And then okay, let's differentiate with respect to, this is to the power 2. Sorry, I'm very sorry, guys. So that's to the power 2. And then what else do we have here? We have partial derivative. So I'm going to differentiate this z so that I can just rewrite it again. It's fine. So that's just x squared plus y squared minus 1 to the power negative 1. So partial derivative of z with respect to y will be equivalent to negative 1 of x squared plus y squared minus 1 to the power negative 2 multiplied by what? Multiplied by 2y, because x is a constant. So partial derivative of z with respect to y is the same as negative 2y upon what? Upon x squared plus y squared minus 1. Okay, so guys, we can rewrite this because we know that we know this. We know that 1 over x squared plus y squared minus 1 equals to z, right? So we can rewrite this like this. partial derivative of z with respect to x is the same as negative 2x divided by z squared. You agree with me, right, guys? You do, right? So this is going to be, no, not z squared, but okay, let me rewrite it like this so that we both don't make mistakes. Hey, and it's easy to make mistakes in mathematics. So that's 1 over x squared plus y squared minus 1, and then we square this, and then also rewrite this. So partial derivative of z with respect to y is equivalent to negative 2y multiplied by, so here there was a squared. Why am I always rushing? Where am I running to? So this is 1 over x squared plus y squared minus 1, and then this is going to be, this is squared, right? So you understand that 1 squared and then the n squared, this is the same as that thing. I didn't change anything. Hope you guys understand. But partial derivative of z with respect to x will be then equivalent to negative 2x multiplied by z squared, right? And then partial derivative of z with respect to y will be equals to negative 2y multiplied by z squared. You guys understand this, that because 1 over this is z, 1 over this is equal to z, so 1 over this is equal to z, then squared, the squared which we had here. So you understand, right? So let's write what they wanted here. Was that we were supposed to prove that partial derivative, so we're supposed to prove that x, so we're supposed to show that x multiplied by partial derivative of z with respect to x plus y multiplied by partial derivative of z with respect to y is equivalent to minus 2z into 1 plus z. So we're going to say our left hand side equals to what? So x multiplied by partial derivative of z with respect to x, I'm just gonna take what? I'm just gonna take minus 2x divided by x squared multiplied by z squared multiplied by z squared is equals to, and then okay, I'm just substituting, guys, and then plus y into, so and then I substitute the 1 with respect to y. This is going to be what? This is going to be minus 2z minus 2y. I mean, where am I rushing to? Is it because of the last coefficient? And then our left hand side is going to be equivalent to negative 2x squared z squared, and then minus 2y squared, and then z squared. So now we are here, guys. We are here. We are supposed to prove. So okay, so our left hand side will then be equals to what? To, if we take what, we take 2z, you can take negative 2z squared, negative 2z squared as a common factor. We are going to get something like what? Like x squared minus what? X squared minus minus y squared. You can see, guys, right? You can see. But then, guys, on our equation, we were given that so this is x squared plus y squared, I'm sorry, x squared plus y squared here. So this is going to be x squared plus y squared, but we were given that z equals to what? Equals to 1 over x squared plus y squared minus 1, right? So if we make y squared, so let's try to make x squared plus y squared the sub root of the formula here. It means we're going to multiply both sides. So this is okay, we're going to cross multiply, and then we'll end up getting x squared plus y squared minus 1 multiplied by z equals to 1. Therefore, x squared plus y squared minus 1 equals to 1 over z. And then x squared plus y squared will be equivalent to what? Will be equivalent to 1 over z plus 1. Then we can take out z as okay, we can just leave it like this. We can just leave it like this, guys. So let's go. Yeah, let's go. So where there is x squared plus y squared, we're going to substitute by 1 over z plus 1. So therefore our left hand side will be equivalent to negative 2z squared into 1 over z plus 1. Okay, and then we can take out z as a what can we do first? We can make we can take out z as the common denominator there. So our left hand side will be negative 2z squared into 1 plus z over z here. Then we multiply this thing here. So when we multiply 1z will chop 1z, so therefore our left hand side will be equals to negative 2z into 1 plus z. So this should be your final answer. Therefore our left hand side equals to our right hand side. So we have shown that. We have shown what we were required to show here. So yeah, that was it, guys. Thanks for watching. I'll catch you on the next video. Take care.